Hello everyone. In this tutorial, we'll be looking at how to write an assembly program in order to find the factorial of a given number. So in order to make this process a bit easier, I have the C++ code for the same present in the left side of the screen. The corresponding assembly program is present on the right. This helps us to see the various similarities between these two. First, let me run the code in order to show you how it's being done. So we use this command spin and we run -f and the file name. So I've named it factorial iteration. So the program works as follows. It asks for the user to enter a number. So let me enter 10 and it prints this particular line which says the factorial of 10 is whatever the value is, and this value is the correct answer. So let us test a few more values. Let's test 4. This is working right. Let's test 6. This also seems to be right. So the program seems to be working fine. So let's go over the assembly code to understand it a bit better. So there are, in this particular code, we have two sections. So we have the .data section and the .text section. So recall this .data and .text from the assembler directives that we discussed in the previous tutorial. This .data section contains all the global and static variables, while the text section contains all the executable instructions. And similar to how a C++ program starts its execution in the main function, the execution of an assembly program also starts at this main label. So, and by the way, these are called labels, which define or which identify different sections of an assembly program. They are written as a label name followed by a colon. And in the data section, we have these following strings, which are the strings that we are printing in this particular program right here. We are printing enter number n, the factorial of, and so on. So those are the strings that are being put in the data section. And note here, we are using the ASCII Z directive, which is also shown in the last tutorial. So this particular directive stores the string in memory and it null terminates it. So let's start with the main label. So first we are printing to the screen enter the number n in order for the user to enter a number, and this is done using system calls as discussed in the last tutorial. So in order to perform a system call, first we need to load the code into the register V0. In order to find the code, we move to this website. So we need to print a string to the screen. So we find the code as 4. So we are loading 4 into V0, and it also says A0 is equal to the address of null terminated string to print. So since we want to print the value input string, I load that particular value into A0 using the LA instruction. Then I run syscall. So once this is done, it prints enter the number n to the output, and then the user enters some value. Now we need to read this input. We need to read this particular integer. In order to read an integer, we come back to the system call list. We see that the code is 5. So we load the number 5 into V0. We use system call. And note that in this particular system call, the result of the reading is present in V0. So the input entered by the user after the system call is stored in V0. We move it to A0 and A1 because V0 is used extensively for these system calls. We don't want to store it and lose the value later. So we move it to much safer places. So in fact, I'm storing it in A0 and A1 here. So this particular part of the code contains the core logic of the factorial. I'll come back to this in a while. We'll first take a look at this particular section. So this whole entire section does basically this particular line in C++ code, which just prints some strings and the actual factorial result. So in order to do this, we print a string again but this time loading out the address of output string into A0. Then we print the original number, which we had stored it in A1. So in order to print a number, again, we need to refer to the system call list. So print an integer is present here, which the code is 1, and we need to pass in the argument inside this A0 register. So in order to do this, we move the value of A1 into A0, and this prints the original number. Then we print the value, when we print the string is, and then finally we print the result, which we have stored it in S0. Finally, we just print a new line and exit the program. So the exit system call is also present in this list. As shown here, the code is 10. There is no arguments or any result for this. So we are done with the printing, basically the input and output parts. Now let us come to the core logic. So how do we actually write the core logic for finding the factorial? So refer to this code. So in order to find the factorial, it's just a simple for loop which just runs over all the numbers from 1 to n and finds the product. Similarly, we need to do the same here as well. So in order to do this, first we store the result in this S0 register. So this is the register that we are going to store the result in. And then we use some construct which is very similar to a for loop in C++. So here we jump and link to the section called loop. So if you go to the loop, this loop section, it's present here. So in this section, we perform some instructions. So basically, what we are trying to do is we are trying to loop over the value of A0 and trying to multiply its value to the result and decreasing it every time. So by the way, comments in MIPS programs are written as follows using hash symbol, which is very similar to Python. So now A0 contains the value n, right? Now at this point, S0 contains the value 1, and we are jumping and linking to this particular section. So now once this particular section starts, so the section performs these following instructions. So first it checks whether this particular value is 0 or not. If it is equal to 0, so recall the BEQ instruction. BEQ instruction checks if the first value and the second value are equal. If those two are equal, then it moves to this particular section. Otherwise, it continues with execution. It's an example of conditional branch statement. So if it after the check is done, it comes down. Now all it does is it multiplies the value to the result. So this instruction multiplies the value S0 with A0 and stores it back in S0. Finally, it subtracts the value. It sets n is equal to n minus 1, and it again jumps back to the loop section. So this particular section keeps on running until the value of A0 becomes 0, at which point we are done with the for loop, which is very similar to this particular place. So we keep on checking a particular condition, as here we start checking I less than equal to n, similar to which here also we are using this BEQ instruction to do this particular job. So this keeps on checking if the value has become 0. So once the value has become 0, it moves to this section loop done, where it just returns back to wherever it was called. So this return address will refer to this point, this particular instruction, the next instruction in fact. So once this is done, once the loop done instruction section is over, it comes back to this position and it starts execution at this point. So all these print statements will start executing. So let me just repeat the loop section a bit once again. So in this section, all we're doing is we are multiplying this value A0 to the result and reducing it by 1. So at the first time we would have multiplied n, the second time we would be multiplying n minus 1, at the third time we'll be multiplying n minus 2, and so on, and the final time we'll be multiplying with 1. after which the value of a0 becomes 0. So once the value of a0 becomes 0, this instruction will jump to loop done. So in that instruction, we are jumping back to the return address, which corresponds to this particular JAL statement. So after this, the control shifts back to this point and starts executing these instructions. So this is a overview of this particular assembly code. So let me just run once again in order to show you. So first, this section has been executed. Now it's waiting for the input. Now when I enter input, let's say 10, it executes all of the following instructions and prints this output. So in the next tutorial, we'll be looking at how to write the same program, basically finding the factorial, but instead using recursion. Thank you.